Good afternoon, and welcome to Wavy Chemistry, where we do not delight in the details, but rather bask in the big picture. Today, I would like to describe the energy changes associated with an exothermic reaction and the differences between a kinetic product and a thermodynamic product using Pokémon cards. Let me show you what I mean. In the Pokémon trading card game, players attach energy cards to their Pokémon in order for them to use attacks. The type of energy and the amount of energy required for the attacks depends on the Pokémon. For example, for Squirtle, we need to attach 1 water energy in order for it to use its water gun attack. This Flabébé requires 1 psychic type to do its pollen shot attack, and Meltan requires 2 steel energy cards in order to use his headbutt attack. We can think of these different types of energy as being the conditions required for a reaction to occur. Some reactions require acidic conditions, some require basic, and some require neutral. And even the solvent that we choose to use for the reaction can have an effect on its outcome. As for the amount of energy, well, that can be related to the activation energy. Chemists describe reactions using a reaction coordinate diagram. On the left-hand side, they have the reactants, and on the right-hand side, they have the products. And in between, there is this hump. This hump is known as the activation energy. It's the amount of energy that needs to be put into the reaction to get it started. Breaking bonds requires energy. So in order to start having a reaction occur, we need to put some energy in. Just like with our Pokémon, in order for their attacks to occur, we have to put some energy in. You'll notice that the line for the reactants and the line for the products are at different heights. That is because the energy associated with the reactants and the products is different. And in the case of an exothermic reaction, the products will be lower in energy than the reactants, and energy will be released. We can think of this as being the damage from our Pokemon's attacks. The bigger the difference between the products and the reactants, the more energy is released, the stronger our Pokemon's attack. So if we think about Squirtle and Flabébé, although they require different reaction conditions, they have the same activation energy of 1 energy card, and they release the same amount of energy or deal the same amount of damage, 20. Meltan, well, Meltan has a higher activation energy, but is a more exothermic reaction. Meltan releases more energy, deals more damage when his reaction occurs. Some Pokemon, like this Mudbray, are able to perform multiple attacks. Mudbray here has 2 different attacks. The first is Smash Kick, which requires 1 fighting type energy and deals 10 damage. The second attack is Mud Slap, which requires a total of 3 energy, 1 of which must be fighting type, and that deals 50 damage. It is also not uncommon for the same set of reactants to be able to form multiple products. Each of these possible reactions will have a different activation energy associated with it. If we were in a low energy environment, so let's just put 1 energy on Mudbray. The only attack it would be able to do here is Smash Kick. In terms of a chemical reaction, we would say this is the kinetic product. It's the reaction that can happen quickest, easiest, with the lowest amount of energy required. But we can see from the stats from Mudbray's attacks that Smash Kick isn't the most powerful attack it could do. That would be Mud Slap. So if we start putting in more and more energy, now we could have a choice. We could either do Smash Kick or Mud Slap. And just like a player would probably go for the biggest, most powerful attack, we find that when there is a lot of energy around, then the most exothermic product tends to form. And we call this the thermodynamic product. The one that forms quickly, that is the kinetic product. The one that releases the most energy, that is the thermodynamic product. And chemists have to tweak the reaction conditions to get the one that they want. There is another aspect of chemical reactions that we can describe using Pokémon cards, and that is a catalyst. The Pokémon card Sparkling Crystal, when it is attached to a Pokémon, it reduces the energy required for the attack by 1. When we add a catalyst to a chemical reaction, it creates a new reaction pathway with a lower activation energy. So just like a Pokémon that has a sparkling crystal attached to it doesn't require as much energy to do its attack, a reaction with a catalyst in place requires less energy and therefore can occur faster, speeding up the rate of the reaction. Throughout this video, we have been only considering cases where the products are lower in energy than the reactants, and energy was released. However, that is not always the case. It is possible for an endothermic reaction to occur, where the products are higher in energy than the reactants. But that is a story for another day. I hope you have enjoyed this video, and if you have, please make sure to like, subscribe, and share it with your friends. And if there is a topic you'd like to see covered in a future video, please put it down in the comment section below. Thank you, and I hope you have a wonderful rest of your day.